Hello, this is our second video about artificial intelligence and test automation. In our previous video, we talked about the potential of artificial intelligence in the field of software testing and distinguished the key concepts of intelligent rules and in automation, as well as machine learning. In this video, we are going deeper into the importance of data, especially for building machine learning models. We will first go through the underlying reasons why the importance of data is generally not recognized in the context of testing. After that, we will go through several different data sources that could be used. To understand why the importance of data in testing is generally not recognized, let's look at how functional testing is typically done. As we discussed in our previous video, much of test automation is actually quite mechanical, or so-called brute force automation, in which a rigid script is repeated every time. So the role of automation is just to perform tasks more rapidly than a human. As an analogy, consider walking along a familiar path in the woods or driving to work. If nothing unexpected happens, you can pretty much take the same path as always without thinking too much. But if there is something unexpected in the environment, humans can adjust their earlier plan in order to reach their destination. This is what humans are actually quite good at, whereas a computer following a rigid script is not. Similarly, in software testing, there are many unexpected things that might happen during the course of testing. Like an autonomous vehicle that is constantly scanning its environment and reacts automatically if, let's say, a person suddenly starts crossing the road, autonomous testing software would need to have a lot of data at its disposal. Suppose we had a rich base of data at disposal, including data about the environment and the execution of past tests and corresponding other information, such as log files. Using this information, it could be possible to spot statistical regularities with the help of machine learning models. We will discuss some benefits and use cases of machine learning models in our next video, but now we will go through different types of data that software testers might not think of. So what kinds of data would we need? On a high level, we can make the distinction between input and output data. Here, inputs refer to different kinds of information that are used to run the tests, whereas outputs refer to the results of the tests as well as information generated during testing. Next, we will go through these in more detail. So what do software testers typically see as data? Based on our experience, data is typically seen as something that is used as inputs in test cases. For example, in the context of insurance software, one piece of data could be an identification number for a specific insurance. This is what software testers typically think of when they hear the word data. Input data can also be data that is populated into the test environment, but is not used directly in the test cases. To continue the insurance example, this would be information linked to the person holding the specific insurance and details about the insurance period. In practice, there are also legal issues to be considered. For example, the test data must not contain real-life personal information. It is also worth noting that this type of data is not typically considered as a data source, and if such data were to be used in machine learning applications, the statistical properties of the data would have to be checked beforehand in order to avoid biases. We can also think about the results or outputs of testing as data that could be used for machine learning models. These outputs can be split into different types. There is the final result of a test, that is a Boolean value that represents a pass or a fail. This is obviously used in testing, but is not considered as a data source typically. Then there are output values that are compared to a test oracle. These output values can be of varying complexity, ranging from integer numbers or text strings to structured data such as JSON or XML files. This type of data is also used in functional testing, but like final results of tests, it is not typically considered as data that could have other uses besides a specific test. The third category of data in the table is data that can be used in root cause analysis. This can be everything generated by the program during execution, including system logs, generated files, screenshots, or video recording of test execution. This type of data is not typically used and is typically not considered as a data source. The fourth category is data obtained without executing the code. We can think of testing in the broad sense, so testing includes tests that execute the code as well as static analysis that generates data by inspecting the code. Also, code complexity metrics fall under this category. In practice, the use of static testing is not that common. Also, like unit testing, it can be considered as a part of software development rather than a separate testing phase. However, here we want to highlight the fact that there are more types of data that could be used for building machine learning models that you might first think of if you only think about testing in a narrow sense or what is typically done. So, there are several potential data sources, both input and output data that could be used in training machine learning models. However, there is still one practical challenge. Typically, the value of data is not recognized, so this means that after functional testing has finished, the data is thrown away after a short period of time, maybe weeks. This is something that came up in our interviews, and while this may not be the case in every organization, we would argue that this is actually quite common and is currently a big challenge for developing machine learning or other database solutions for improving test automation. It is actually quite simple. Without data, there can be no machine learning based testing. Thanks for watching.